No, we didn't start yet. All right, people who are watching this should be Wyatt and Aubrey. It is Friday. The kids don't want to do anything, but I'm not letting them do that. We have to do something, and it is the Pythagorean theorem. We're doing section 9.2 before section 9.1 because the Pythagorean theorem is easier. So, yes, ma'am. Aha! Look at you. Are you going to post-prom? No. Okay, awesome. Go put that over here in this corner by Jordan. Just like sit him on the top of that corner. Right? You see that? Right there. Yes, sure. Awesome. Perfect. Thank you.
Bye, Kenzie.
Okay. All right, Pythagorean theorem. All right, one thing that I want you to write down for the Pythagorean theorem. Pythagorean theorem only works for? Only for right triangles. Okay, do you know what the Pythagorean theorem is? Right. Okay, now, A and B. It does not matter which sides A and B are as long as C is the longest side or the hypotenuse, right? C has to be the longest side. A and B can be whichever ones you want to. You can flip them around. I don't care. All right, now, the nice thing about the Pythagorean theorem is that, yes, we're only going to use the Pythagorean theorem for a right triangle, but I can use the Pythagorean theorem to determine whether it's an obtuse triangle or an acute triangle and not a right triangle, okay? I can use the Pythagorean theorem in such a way that it will tell me whether it's an acute triangle or an obtuse triangle. So that's the part that you haven't probably learned already before. So there is a little tidbit in here of stuff that we need to discuss. But first and foremost, let's go through example 1 and let's solve, okay? A squared, B squared, C squared, we're solving for X. Which side is X, A, B, or C? C. It's the opposite of the right angles, so we're solving for C. So 17 squared plus 7 squared equals X squared. 17 squared is 289, is that true? Plus 49 equals X squared. Somebody check that. Okay? 338.
289, dumb. Yeah.
When you add the 49, it's 338. Okay, take the square root of 338. What? 18.4. Awesome. There you go. 18.4. All right, now, I'm going to go back up here, and this is what I challenge you. This is what I challenge you people who know the Pythagorean theorem. No. Be quiet. Shh. Here's what I challenge you people who know the Pythagorean theorem already, like very well versed in the Pythagorean theorem. There are triples that help make life go faster. We've talked about these already before. There are two that I want you to memorize out of this list, okay? And they are 3, 4, 5 and 5, 12, 13. Those two you will see in at least 2 or 3 problems on the ACT. They will throw that little shortcut in there. That's fine if you don't remember those. You can do the A squared, B squared, C squared, but you're going to save time if you can remember those. Now, below a 3, 4, 5, let's say we have a triangle that has, it's a right triangle. This is 6, this is 8, and they say solve for this guy. That is a 3, 4, 5 right triangle. 6 divided by 2 is 3, 8 divided by 2 is 4. This would be 5, but to get that number, I have to multiply by 2, so it's actually 10. That's a 3, 4, 5 right triangle. You're using that shortcut to find the remaining side. And you can do that if you know the triples, right? 5, 12, 13 is another triple. 8, 15, 17 is another triple. That's one that people like sometimes will have memorized. Sometimes they'll throw that in there. I challenge some of you people to memorize that one. 7, 24, 25. There's also, if you want to add to this list, 9, 40, and 41 is another triple. There are more than those. But I took a college class for my master's that was talking about Pythagorean triples. And there are some other Pythagorean triples that go up into the 3 digits, right? Like they're 3-digit numbers, like 127 and whatever, right? But they're like huge numbers, right? You'll never see those probably in a typical math problem, right? Okay? It's not worth it to memorize those. But here are 5 of them, 9, 40, 41. I'm going to add to that list. Those are the ones that are 2 digits or less, right? Those are the Pythagorean triples that work that are 2 digits or less, right? Okay, now, not every right triangle you use the Pythagorean theorem on has a triple. For example, the one that we just did had 2 numbers that did not have a decimal, but the third one was a decimal. Pythagorean triples are specifically ones that don't have decimals for any of the numbers. Got it? Okay, so memorize those. 3, 4, 5, 5, 12, 13. I will ask you those again, like probably every day for the rest of chapter 8 or chapter 9. Got it? Memorize those. Bonus points if you can remember these two. I think I might ask you that on a test. Get to memorizing them now. 8, 15, 17, 7, 24, 25. Maybe that might be a good bonus question, okay? All right, so here's the deal. This next one. Use a Pythagorean triple to identify this one. All right, how do we use Pythagorean triples then to like do this?
24, 25.
It's a 7, 24, 25. So I look at these two numbers that I have, right? What can I divide those by? 2. I can divide by 2. So if I divide 14 by 2, that becomes 7, right? If I divide 50 by 2, that's 25. And so this side has to be 24, but it's not 24. I have to
48.
multiply by 2, which is 48, right? That was way faster than plugging it in, right? Got it? 48. Each one of those numbers was divided by 2. 48, if you divide by 2, is 24, which is the missing side. Got it? That is way faster, okay?
I don't get it.
You don't get it? Let's do the check right here, right? Okay, 48 and 20, what can you divide by? I'm going to divide bigger. 4, I like dividing by 4. That sounds good. Okay, if I divide by 4, 48 divided by 4 is 12, right? If I divide 20 by 4, that is 5. This is a 5, 12, what? 13. But I have to multiply him by 4 to get him back up to the number, right? And that is 52. So the hypotenuse is 52. Do you see how that works?
What's the homework? Okay.
Okay, because 5, 12, 13 is a triple. It's one of those ones I told you just now to memorize. 5, 12, 13 is a triple. Okay? 5, 12, 13 is a triple. So if one side is 5, one side is 12, the hypotenuse is 13. Got it? Okay? Do you see how that works? Yeah, so it's faster. It's just going faster. Yeah, okay, I like it. All right, next one. How long must, I'm skipping to the last sentence. How long must the zip line be? That's this guy right here. That's the slanted line. Those numbers are very, very large. I'm just going to plug them in. Which side is missing? You want to divide by 25? Does it come out to be nice, though? Yeah, I don't think it's going to, I don't think dividing by 25 is going to help, like, make a triple. It might just be a decimal. This is side C, so which one do you want A to be? Sure, okay, grab a calculator. 450 squared plus 775 squared equals C squared.
Oh, what the heck?
What?
3,125.
If you add them together?
Yep.
8,
803,125.
125, okay, equals C squared. Take the square root.
896.2.
Okay, now that answer should be the largest side, is it? Okay, then I'm guessing we probably did it right. On the ACT, you will be surprised at how many dumb answers they put in there. There will be at least 2 obviously wrong answers. What would be an obviously wrong answer?
32 million.
Anything smaller than 775 is an obviously wrong answer, true? Because it has to be the longest side. Yeah, like any of those would be an obviously wrong answer, right? Okay. What? That would be an obviously wrong answer for another reason. No. Okay, all right. Turn your listening ears on if you've been tuning me out up to this point, because this is the hard part. Ready? Okay, this is where we use the Pythagorean theorem. Okay, I'm going to go down here to this spot. Okay, we're going to talk about right triangles. Right triangles. Okay, and then I'm going to have you do a little thing over here that talks about an acute triangle, and then talks about an obtuse triangle. Got it? Put those 3 sections at the bottom of this page. Okay, put those 3 sections at the bottom of this page. All right? If you have a right triangle right here, like A, B, C, here's a right triangle. It will be true if it is a right triangle that A squared plus B squared is equal to C squared, yeah? If it is a right triangle, that will be true, hands down, 100%, yeah? Okay, here's the deal. Do you know what an acute triangle looks like?
A squared
like, that looks like a right triangle.
C squared.
Yeah, maybe like an equilateral triangle. Okay, here's the deal. Are you ready?
A squared plus B squared is greater than C squared.
Yeah, a squared plus b squared in relationship to c squared. Okay, here's the deal. Here's how you remember this. If it's an acute triangle, all of your sides are fairly small. You don't have one really, really big side. Okay? Your biggest side is still C, but when we do this, we're saying that C is still a relatively small side. So a squared plus b squared has to be bigger than c squared because c squared, even though it's your biggest side, is still relatively small.
Line on it
Okay? What? What are you talking about?
from the triangle.
Why did I what?
Leave the line.
Because I originally did him like this, and then I'm like, no, that looks like a right triangle, so I took him off. Whatever. I'm just, whatever. Okay? So, a squared plus b squared is greater than c squared. All right, in an obtuse triangle, I do have one really, really big side like this, right? Okay? So, a squared plus b squared, and then I have c squared. C is my longest side, but c is a really, really, really long side. So it by itself is going to be huge in comparison to even adding those two together. Does that make sense? Your biggest side is a big side versus your biggest side being a small side. Does that make sense? Okay? So that's how you tell acute or obtuse. We haven't done that ever before, probably in another math class. So that's how you use the Pythagorean theorem elsewise. Got it? Okay. All right, here we go. Example 4, this is the last one, and then we're done. Here we go. Determine whether these guys make an acute, a right, or an obtuse triangle. First and foremost, we got to find the distance of all of the sides. So let's go AB, and let's go BC, and let's go AC.
We're not getting away from this distance point.
I know you're not. Oh, and you will probably have at least 2 problems on the ACT that are distance formula problems. And or the midpoint formula. You do that a lot. Well, because the distance formula is the Pythagorean theorem, truly. Okay? All right, if I go AB, how far apart is 2 and 5? 3 squared. 2 and 7? 5 squared. That is 9 plus 25, so that is the square root of 34. Leave it like that. 34. Okay? There you go. BC. B is 5, C is 10, that is 5. 7 and 6, that is 1. 25 plus 1 is the square root of 26. Okay? Last one, AC. 2 and 10. 8. 2 and 6. 4. This is 64 plus 16. That is 80. The square root of 80. Okay, which one is your side C in this case? 80 or AC has to be your side C. Let's just go A, B, C. Okay, C has to be the largest side. It doesn't matter what we name the other two. Okay, so if I do A squared, hold on. If I do A squared, this is the square root of 34 squared plus the square root of 26 squared is in what relationship to the square root of 80 squared? Okay, so here's the deal. Sienna just said when you square root and square, they cancel each other off. That's why I don't want you to put them as decimal numbers, right? Okay, so go ahead and do that. This is 34 plus 26 is in what relationship to 80? This guy is how much? 60? 60? Okay, so that means my biggest side is really big, which means obtuse. Do we see how this works?
What's our homework?
Your biggest side is a really big side. He's an obtuse triangle. Got it?
What's our homework?
Okay, so there's more to just the Pythagorean theorem than just the straight a squared, b squared, c squared, right? You can use it elsewise. All right, here we go. Here's your homework. Woo!
What's our homework?
Yeah. Could you tell us what our homework
You just hush it.
Hush, Poppy.
That sounds good.
Ew, those make me puke. Oh, it's like literally grease.
Actually,
Not so
commentary.
I want Taco Bell.
All right, let's just do this.
That's their,
There you go.
like, so there's welding.
2 through 22 evens.
There's 4 types of welding.
That's 12 problems, technically.
Why don't we ever do odds?
You
Because I know you, Trevin.
Because they're in the back of the book.
Trevor's too innocent to know why we don't do it.
No, he's not.
No, he's not.
He's never innocent.
Oh yeah, acting
So you
innocent.
said
I thought Trevin was innocent until the day
what day?
that he exploded a Dr. Pepper can in my classroom. And now, ever since, I know Trevin's true colors. I know.
I'm white. Go in, Jess.
Said square root of 80 is bigger than the square root of 34 over negative 26.
Yes.
Square root of 80 equals 829.
Squared, though. You have to square them. A squared plus B squared in relationship to C squared.
Oh,
So, Brady, right here.
Oh, yeah.
Yeah, when you square them, the C side will still be bigger. So you got to look at the square, not the individual. You got to look at the squares. Okay? All right, goodbye, people watching this video.